Okay, so let's discuss a question on machine design. So what is given is an actual 1 meter long is supported at bearings head. So it's an example of simply supported where you have one end, both the ends in the simply supported case, and you have at the center. So this portion is this portion is all supported. Okay, there is a simply supported, and you have a flywheel at the center. Okay, so you have a load W carried at the center, and you have the length L of the shaft. Okay, this is actually simply support, actually something which carries uh, basically which supports only bending movement. It's something like in the bore well you have, right, to uh, from the well, if you want to, you have a pulley attached to the axle, and from there you take the bucket of water. Okay, so there you can find out. So that doesn't rotate, that only supports the pulley. So something like that arrangement you have it here. And we need to design the axle. So we need to basically find out the diameter of the axle. So for that, treating this axle as a beam, so basically we need to draw the bending moment diagram. And if you recall, the bending moment diagram of this case would be simply something like this, because you have a concentrated load W, so the reactions will come from W by 2 and W by 2, and W by 2, W by 2, and when you take W by 2 into L by 2, so this value will be WL by 4. This is the bending moment diagram. So from your bending moment, if you draw it, so this is the bending moment diagram. So this bending moment diagram, if you find out, yeah, so this is the maximum bending moment. So obviously we need to take at this point, we need to design it because it's a constant diameter. So the maximum bending moment is WL by 4, and we basically use the bending moment theory, bending moment formula, which is M by I is equal to sigma by Y. So sigma will be My by I. M is M, Y is D by 2, I is area cross section, area moment of inertia, which is pi by 64 D power 4. So this comes to be M 32M by pi d cube. Okay, so this is the formula for the stress. Okay, and the limit, we have a limit for this stress, which is 60 MPa. Okay, so this has to be the 32M by pi, has to be less than 60 MPa. So let's substitute the values. W is given as 30 kilonewtons. So 30 into 10 power 3 into L, which is 1 meter, by 4. So it's WL by 4, and then you have pi, and you have diameter, which we need to find out, d cube. So this has to be less than 60 MPa. So we get the diameter in mm only directly. So calculating this, we get diameter, which is 108.3, and this is just, everything is known, only you need to calculate here. Somehow this pen is not behaving, the recording pen is not behaving well, so bear with me. 108 MPa, and so it's roughly 110 mm. So 110 mm is the diameter, which basically satisfies and the stress within allowable limits of 60 MPa. Thank you.